right. Should we start? Now, I can't see you guys. Actually, I see Mark for some reason. And apparently I can't see chat. So if you have questions along the way, just interrupt me. So we are good to start, right?
Yep, go for it, mate. We are recording.
Cool. So I'm going to show you guys some stuff I've been working on in my free time. It's actually going to be two libraries. I'm going to skim through one and then show you how the other one utilizes it pretty much wholesale. So I will cover both of them. And I can't do a quick show of hands, but this is going to involve SVG paths. It might even be a good complement to the previous talk because this is going to be very 2D, not 3D. One of those libraries is this guy right here. This is my repository. The library is called Path. It's a really simple, dumb library that lets you generate path commands. So if you're not familiar with an SVG path, it's a path tag. It has a D attribute, and into that goes a bunch of these commands. M for move, L for line, a lot of different coordinates, things of that nature. And this library is really, really simple. It just gives you all of those commands. If you've ever used, I don't know what the equivalent today would be, but you know, when I was a very young man, they had a thing called logo, where you said like move the thing forward, you know, pick the pen up, move the thing right, and you would just draw these lines or move to whatever space you needed to. And Path very much works that way. And what I've done is I've just made functions out of all the existing commands. And then I made some nice little names for them. So you got line to, move to, whatever, different types of curves. Some little helpers, down, up, right, left, close. And then I have this thing called macros, which very simply lets you take a bunch of commands and save them. So here's my command to, or my commands to draw a square, and I save it as square, and that becomes path.square. And it just creates it for me. There's a little documentation page here on this. You can take all of these really simple, basic commands and create some, you know, much more elaborate stuff than just squares and things of that nature. Built into the library are a whole bunch of the macros, but you can create your own macros. So you can just say path, you pass it in, or path.macro, you pass it in a name of your shape or whatever in a series of commands, and it becomes part of the library. So you're really just adding a prototype onto the base class. So here's a whole bunch of shapes. But it's important that I point out that all of these are paths. So for an example, this is a circle, and there is a circle SVG element, but this is a path. So you can see I'm highlighting that right there. It's not a circle. It's a path element. Everything in this library will produce a path. So if you say circle, it's going to give you a circle shape, but it's drawn from a path. Everything. There's all sorts of groovy stuff in here. The other library I'm going to show you is called react-svg-path. And I'll get to some code in like just a second, but I just kind of need to set this up so you understand how I took a shortcut to showing you how this works. So this is a React library. It's a different library, but it has, outside of React, it really only has one dependency. There's a bunch of dev dependencies for code formatting and building it up and everything, but its only dependency outside of React is actually the library that I just showed you. And the way it uses that library is if I go in here and go into components, you're going to see there is a component called path. And this is all it does. It imports the original library and it adds this toComponent method on it. So in this case, we're using JSX. It just renders a path along with utilizing the method that already exists, which is toString, which is take all the paths that I've built up and output a string, add to this path any of my attributes and any props that were passed in. That's all it does. So it imports the entire library wholesale adds one thing to it. It also does this stroke width thing, but just ignore that because I think I'm going to get rid of that. It was a dumb idea in the original library. It's really not needed. So here on the left, I've got a little React application running. This is just create React app. The only thing I did was add react-svg-path, which is the library I was just showing you. And I stripped out all the shit that was in here. So that's all gone. So when I import path here, this is that component I was showing you a moment ago. This is that path library, pretty much wholesale. And just some quick setup here. I've got a size, a center, which is size divided by 2, a quick margin. This is all kind of standard setup if you're doing any sort of stuff in SVG to make sure that you don't hit the edge of the SVG. And what I'm going to do is say const p equals new path. All right, so I've got a path here. And I'm just going to just kind of very, very briefly show you how the kind of source library works. So here's a path element here. I'm going to set its D attribute, which I think is data, but this is where you send all the commands. So you can't see it yet. This is actually moved to, but I've moved the cursor to the 0, 0 coordinate. And I'm just going to say right by size, which is S in this case, and you can see that black line appeared at the top. I'm going to say down by size, and I think you can see where I'm going here. Left, and then I can just do close. So that's how the underlying library works. With those macros that I showed you earlier, this could have just been square, whoops, which takes in a CX and a CY, which is the same in my case, and a size. So, oh, you know what? Sorry, size goes at the beginning. So same square, I could change it to whatever. So that's how the underlying library works. You can just kind of chain all of these commands. You can even chain from square back to line or whatever. And I do just want to point out very briefly, there are some kind of guarantees. When it comes to these basic shapes, every single one of these will say that the shape is drawn from the center point, and then the cursor is moved to the center point. So you get this promise from the library that the ending point and the beginning point are always going to be the same on these guys. And that becomes important later, not right now. And then the other one is that whenever you draw one of these types of shapes, like a regular polygon or a polygram or a star, you're always going to have a point at the top. The first point is always going to be at the top. So if you've ever done any geometry stuff and you start trying to figure out like radial points, you end up with like a square on its side and you meant to have it flat. This one is always going to give you that first point at the top, no matter what you do. So what the react-svg-path does is actually really dumb. It just takes all of these and turns them into components. But then because it's React, we can add some interesting behaviors. So I'll start off very simple and just say we're going to throw a circle on the page. I don't need to deal with any of this kind of functional looking programming any longer. And I don't need a path. I need a circle. And circle works the same way as the command. It takes in a size, which is going to be equal to S, which is my size up there. It takes in a CX, which is C in this case, and a CY. And I should probably switch back to the app. And you can see we have a circle. So the idea here, for me at least, is I end up doing a lot of data visualization in SVG. And for that, I end up relying on a lot of libraries like D3, a library I'm a big fan of called Dagger. And I run into a lot of situations where I really have no idea what went wrong. And so my motivation for building this library is I want to know where I screwed it up or where, I messed up some crazy combination of geometry, mathematics that went into some library. So we're just going to play with this a little bit. Like I kind of have a destination, but I just want to kind of show you how this works and some of the like things I really enjoy about it. But obviously right now, this is like fairly simple. I'm going to jump over to the documentation for the React library. And right off the bat, it's kind of important that, I let you know, yes, you can do all of this kind of groovy data visualization stuff with it. You can couple it with something like D3. I know this chart actually uses D3 for one small part of it to figure out a certain scale. The rest of these I don't think use D3 at all. I know they don't. You can see in the path stuff, it's basically wholesale, the other library that I showed you. And then I explained the two component thing here, like where I created a triangle component using the path library. I return this two component thing, and now I have a triangle component that I can just, render wherever I want and not really think about a lot of the math behind creating a triangle, I guess. All of these guys have like little dials on them, at least where they're using numbers. If I go to something like a polygon, I haven't created the knobs for this yet. But there's like really fun ones too. Like polygons are crazy. Like I can add a whole bunch of points to this and then mess with this vertex skip thing and just create all sorts of spirography kind of things. Radial lines is kind of an important one. I'm going to use that now. All this really does is it figures out these points around an inner circle and an outer circle and then draws a line from the inner point to the outer point. And as I change these things, I get, this is updating in real time. So I'm just going to copy that. I'm going to switch over here. I'm sorry, somebody say something?
I said that's cool.
Yeah, it's neat.
So,
I'll actually talk a little bit about that because this has been a huge learning experience for me, building something that I'm kind of getting close for the world to see. But right now, it's just you guys. So ixnay on the sharing.
oh man.
So I dropped this radial lines component in here. And what I'm going to do is I'm going to give it an inner size of 0, an outer size of our size, and then a cx of our center and a cy of our center. And look at that. I made a Mercedes symbol, right? I mean, if anyone wants to applaud now. Okay. So I do want to point out again, and I don't mean to be redundant, but it kind of starts to become important. These are just paths, right? So an interesting behavior, and this is where things for me start to become like, oh, this is super useful, at least for me, because while I've put a lot of time and effort into relearning 8th grade geometry for this project, I hate it. So what I'm going to do here is something you can't actually do in SVG. If you Google how to center text inside of an SVG rect, you're going to find that question like a million times on Stack Overflow. And so what I'm going to do here is I'm going to drop that radial lines thing. Oh, kind of cleaned up on me. I don't need this much space over there. I'm going to drop that inside the circle. And of course, like everything's the same because I didn't change anything. But one feature of the library is if you nest something, it will inherit as a starting point the parent's ending point. Now, in this case, circle, radial lines, both start and end at the same, they start in their center. So what ends up happening is I can just get rid of this CXYX. Now I'm just saying I have an inner size of 0 so that the lines connect. I have an outer size of the same size as my thing and 3 points. And now it just works. Like I don't have to think about positioning that even a little bit. And that's kind of cool. So here's where I start to get hazy on the middle part of my presentation. So I'm just going to run with stuff and just start doing things and try to remember why I was going to show them to you. So I'm going to go a little bit further here, and we're going to bring in a line. Just a plain old line. Just to kind of show, because when you're using shapes, this whole idea that everything is going to begin and end at the center makes like nesting shapes really easy. I can put a square inside of here, whatever. I can technically make it bigger than my outer shape, but it's always going to have that same center. Whereas a line, at least in my library, starts with an SX and an SY. A line is, it's just what it sounds like. It's going to have a starting X and Y, and it's going to have an ending X and Y. But because I'm going to inherit from circle in this case, even though I could have just as easily nested it inside of radial lines, all I need is an EX and an EY, because I already know the starting point. Or if I don't give it a starting point, it's just going to inherit it. So in my case, I'm also going to just say on the EX, I'm going to say 0, because what I can do is I can say this guy is relative. So now this line is going to be relative to its starting X and Y coordinate. So I don't have to worry about the X, because what I want to do is I just want to go down from the center, size divided by 2, and it's like kind of like a peace sign, right? So that line just goes from here to there. But again, I didn't really have to think about it. And as a software developer, I mean, that's important to me. Like, don't make me think. So a lot of this like composability was what I was going for, and React certainly lends itself very well to that.
Joe, Joe, I got a question. Why did you need relative for that? Isn't EY?
Because otherwise EX and EY are absolute positions. So if I get rid of relative, it's going to end on the X of 0. So once it's relative, the X is basically saying don't change from your SX, your starting X. You follow?
And why so can you type in SX and SY, what they would be in each case? I'm sorry, I'm not quite there with you. 0, right?
See. Oh. It's this center point right here. If you can see my mouse, this is the center that it's inheriting as its starting point.
Oh, see, I thought of it as you were setting up a new coordinate system at 0, 0 of the circle.
No. So
I've done a lot of SVG stuff, and so
in this case, it inherits. So C is center. It's because I'm drawing in a square. My SVG is a square. This is the only component that has an X and a Y coordinate. So that's kind of tricky, but it's, because I tried to explain earlier that all these shapes start and end at their center point. So what this inherits as its starting point, or in its case, the CXCY, is the CXCY of the parent. And this, because its starting point is SX and SY, it inherits the CX and CY as its SS, XX, and SY. And I can elaborate that on that just a little bit further. But what I will tell you is like almost every single component in this library either starts with an SX and an SY or a CX and a CY. And so you'll always inherit, if you're inheriting from a shape that is based on its center X and center Y, that's what you'll inherit as either your center X, center Y, or your S, start X and start Y. Do you follow?
Yeah, it just wasn't what I expected at all. So that's fine.
Okay. Cool.
I thought you were moving the coordinate system to 0, 0 at CXCY.
No, so a line, and this is in the documentation. I think you'll actually get a kick when I show you. You'll get a kick out of it when I show you the documentation, because I know you just did the thing on Storybook.
It looks like Storybook, yeah.
It's very nice. With Storybook, but I feel like I've come up with something really cool. Like I might have an idea for a whole new library.
Excellent, excellent.
So I was going to say that this isn't quite a peace sign. There's a component in here called sector. I'm just going to grab this guy because a peace sign, I actually compared it, and I was like, that's not actually a peace sign, because a peace sign actually has kind of a sharper angle. And I just, want to show off some of these components. So this is a sector. If you missed it, a sector is basically kind of a pie shape. There's another one called a
Pac-Man.
segment that is unclosed version of that. And that's how I end up making in some of the examples that I was showing, like donut charts, pie charts, like super simple. You give it a center, X and Y, you give it a size. I've kind of avoided anything that requires a radius. I don't want to think about a radius. I just want to pass in a size, and the library can figure out the radius if it's needed. And then you give it a start and an end angle. So in this case, this is 0. This is 270. There's my component. So in this guy, I'm going to drop in a sector, right? I just copied that out of there. I know I'm not going to give a shit about the center position because I'm going to inherit that. My size is going to be the size. And I know this because I tried it earlier, but I could be doing it backwards. I'm just going to save that guy for a second. Oh, you can see our new lines there. I'm going to kill the radial lines. So we're getting closer, except now on this guy, I can't start in the center anymore. So I need to do, I basically need to move from the center by 250, and I'm cheating because I know C is 250. And then my ending, oh, no, that's not right. I know why I was doing this. Hold on one second, guys. So you can override the starting position, but like I said, in this case with the line, because I've added relative, the end X and Y are going to be relative to the starting X and Y. But again, I don't want to think about the starting X and Y, so I have an OY, which is offset, right? This prop is only used when you're nesting components. And you can use it on any nested component. And what I'm saying is I want to offset from the starting or the Y coordinate that I just inherited. So I can just say minus size divided by 2 because I'm in the center. And then that's going to get me part of the way there. And then all I need to do is say go the full length. And I've got an actual thing that looks like a peace sign. So we're going to compose some more stuff here. But like this is where like I kind of start to really dig what I've made here because, yeah, there's some little math. But like when something goes wrong, I can look at my code that I wrote and I know why it went wrong. There's very few, I don't even like to call them rules. There's like a few promises or guarantees that come with the library. And they always involve nesting, how a shape is drawn, and in particular on polygons where your first point is going to be. And those aren't there because like I just decided them. I realized like they're super helpful to me personally. And I mean, if you're building a library and it's not useful for you, fuck your library, right? Mark, you counting?
Full.
All right, so I'm going to go back to this radial lines thing, and I'm going to give it an inner size. I can't remember what that's supposed to be, so we're just going to mess around and say s times 0.95. Let's see what that looks like. Short, say 8.5. And you can see there what I did is I shrunk the inner size, right? So the lines got longer because the inner size got smaller and it draws to the outer size. And I'm going to tweak these guys. I'm going to say 4. Cool. And then here we're gonna let these guys be a little smaller, and I'm going to say 60. Does anyone know what I'm making?
That is so cool.
We could even, if we wanted to have one in the middle here, 90, we'll say 12. Now we've got 12 markers, 4 of them are longer, and 60 little ones. Are we getting, like, somebody knows what I'm making, right? So
yeah, when are you going to put the second hand in?
Yeah, thank you. Somebody was listening. So one thing I want to point out here is, again, all of these are creating their own individual paths. And that is totally acceptable. There's nothing wrong with that. But you may create something like this. You know, I was showing you how you could make those macros with the base library. And you can write all these commands together. Move here, do that, draw an arc, all this cool stuff. And then you can create your own macro for that and have that forever. But when you're working in the React library, you have all these existing kind of macros. That's what each of these components represents. It's kind of easier to say, well, I just put this together. I certainly don't want to go back and figure out what all the underlying path commands were. So I introduced something else. So there's two things in this library that really I have not seen done anywhere else, and I really like them. And the first one is this ability to nest things. And the second one is this guy. So I just wrapped all of these components, 3 of which are nested inside of another component, inside this new component called path merge. And what I get, all of that is one path now. So there's no more multiple paths. It's just all of this stuff. Everything you see here is now just one singular path. That may be useful to somebody. I have found it useful.
Wow.
It does mean that you're kind of, because you're doing that, if you want to change like the stroke color, it now applies to all of it. So there's some trade-offs there. But you may have a shape here that you just want to fill in color or whatever, or maybe you want to get down and dirty and start doing some awesome gradient stuff. You could definitely do that. So we need a second hand, Marcy says. I wasn't planning on that, but she decided for us. So I have a couple utilities here. One of them is called time, and I'll just show you these really quick because they're super stupid. There's no React in this at all. This is just give me an object with the seconds, minutes, and hours. Nothing special going on there. And what I'm going to do is I'm going to add a line, right? Now I'm going to go ahead and keep it outside of the path merge for now. So I actually have to give it the SX of C and the SI or SY of C. And then the tricky part is I have to figure out where it's going to end. But included with that utility thing is another one called degree to angle, which I realize now is actually really poorly named. But what it takes in, I will have to go look and remember. I'm just going to copy these guys because I'll forget switching back and forth. Is the value. For us here in Chicago, it is 7 o'clock. We're going to call this the hour line. The division, which is 12, we have 12 hours. I think that's right. It needs the CX and the CY, which in both of our cases is the center because we're drawing in a square. And then it needs, I'm going to say, hour hand is the shortest hand, right? I'm going to call it 0.8. So it's our size. And what this, oh, that's not what I meant to do. Takes on a radius, maybe it's that way. Nope, screwing it all up. This is what happens. So size, this make it a lot smaller. That'll fucking work. No, it didn't work.
Does relative mean anything in this case? Because you're not nested.
Thank you, Steve. Linters.
Look at that.
So that should be, yeah, I'm just going to make it go all the way to the edge. So that's not, is that 7 o'clock?
Ish.
Yeah, whatever. I'm not going to sweat it that much, you guys.
The line itself is starting slightly too far to the north.
Mm-hmm.
Yeah.
So we're going to tie this to the actual times, and then all of a sudden it's going to miraculously start working, I think. So
Put it inside your transform. You're outside your transform. That's the problem.
I am outside. Jesus, Steve, you're the best, dude.
I've done a lot of SVG.
Look at that.
Fucking personal linter. I love you right now. So I've got this function called time, and what I'm going to do is say this is time dot hour. This is time minute. So we'll make this, you know we're going to make this work, right? and this is time dot second. I'll format that so we can see it all. And there it all is. It's not awesome, but we'll give these a color so we can see them. We'll do blue on the hour, green, and then second has to be red, right? And then we'll tweak these. So I'm pretty sure. Yeah. That's what I'm going to do. So I'm pretty sure hour is the shortest. And then, like, I think minute and second are like the same, no? You know what? That's what I'm doing. Piss off. All right, so that's what time it is. We're going to make this a bit more React-y. So we're in React. We can use React. So we're going to set up a use state. I'm going to set the initial state to time. If you're not familiar with React, don't worry about it. I'm going to Google, unless somebody has a snippet. That'll do. Load this back up. And here we're just going to set state to time. We're going to jump down here and change all these to state. Again, if you're not familiar with React, this part isn't that important other than, oh, I know why these are off too, by the way. So this value represents a division. How many slices are we dividing it into? These should be 60. So now that is the correct time.
That is the correct time.
Sorry about that.
Damn.
So yes, I mean, I did have this degree to angle thing set up, but I mean, technically all it's doing, like, I just Googled, you know, some basic math, and I already had a thing in the library called Polar to Cartesian that I thought should have done this, but it didn't do it. And then I was like, you know, whatever. Part of the reason I created this library is I don't want to do a lot of that basic kind of geometry stuff. I just want to move things around and see how they look and build a thing. And yes, you can do a lot of like groovy data visualization, but if you want to like actually have control over what you're putting on the page and not have to translate from something like D3, which is doing a lot of DOM manipulation, to something like React, where you can just have this kind of declarative method for creating all these shapes and figuring out, you know, the important bits rather than a lot of the stupid bits. Like, it does that for you. I'm going to show you just definitely, I think, I don't know, my notes suck. I'm going to show you at least one more thing. And that's if you've ever used SVG, there's this concept of markers. And technically, like, I give you the ability to create a marker out of anything. I'll actually just show you really quick in the example. So if you're not familiar with what a marker is, it uses this syntax on any path, marker start, but in regular HTML, it's marker dash start, marker end. And you're saying I want to add a symbol to the beginning or end of my line. So here's marker arrow, right? That's at the start of all of these. Here's marker end as a triangle, right? So now they all have that. Marker mid really doesn't make sense on a lot of shapes, but since this was the end and this was the start, this was the end, all these triangles are at each midway point automatically. And just to very briefly show you how that works, I'm going to bring in marker arrow. I'm going to jump back over to our app so we have it and we can see it. And so I know I can't see everybody, but if you've ever used a marker on a path in SVG, you have to do all this definition stuff, which I don't like doing. And so I got rid of it. So all I have to do is give it an ID. So I dropped my marker arrow in place. And I'm going to say marker H, right? And what do we make our blue? I'm going to give it a color of blue. And then I can come down to my guy for hour and I can say marker end equals, and again, this is not something I invented. I just made it easier. So you have to do this type of syntax. You have to get that, what I just call it, marker H, right? And now it's got a little blue marker, right? You can see it? No? You don't have to clap every time, unless you really, really want to. So we'll just go ahead and set those all up. So, I mean, the interesting thing here is, I don't think I'm going to give it a shot, but, if I wanted to add numbers around this guy, it really wouldn't be that complicated. If I wanted to take this and turn it more into maybe like a gauge, that I could pass in a value to, like we could, you know what, fuck it. We can do that. Let's do that. Sector, right? We just had this thing. This is basically what it is, right? So we'll just drop it in here. It's a sector. Actually, maybe I'll put it in here. Maybe? No, because I want to give it a different color. Fuck that. We're going to put it after all these lines because if you know how SVG works, the last thing is the thing. And yeah, you know what? This will be easy. The CX is the same as everything else. And this is all I need to figure out. And I'm going to give it a fill. Okay, so we got this. And then I'll show you some library stuff and I'll quit fucking around. But now I want to try this. Let's just see if, okay, it does show up. And now and let's make that not so dark. I just need to figure out, you know what? I was kind of thinking I could use this degree to angle thing, but that actually returns 2 points.
Welcome to the inside of Joe Maddalone's head.
It's cozy.
I think I got this shit. There you go. So it is filling that sector with every second. So so I didn't make a gauge, but you could see how that could be a gauge. That could be a gauge. It could be animated. It could go to a certain level. You could have like a red sector that says this part's dangerous. You're going too fast, or you've got too much CPU usage or something. You could do it. And again, that's what I've really been enjoying about this thing is you can just kind of take some of these existing pieces, turn them into new pieces, repurpose them, do whatever. On the introduction page for this guy, I made this chart. I made this chart. I made all these charts because if you want to talk about SVG, you have to have charts. But what I really enjoyed making was this 2-scale NFL football field. Like that was a lot of fun to make. And coming up with a little thing that does dimensions is what led me to doing markers. And this dimension thing just uses a line and it inherits I have to offset to the center of the line, but since I know the length of the line, it's very easy to create a rectangle in the middle of the line and add some text. And all of this is, I mean, it's the code that goes into this. Not the library code is actually fairly smart, but the code that goes into making these charts is fairly dumb stuff. Like this one does use D3. But none of these other ones do. No, like this pie chart has no D3 or anything in there. It's some really basic stuff, and it just produces how many sectors you need with their start and end angle. That's it. Okay. Am I okay on time, Mark?
Yeah, you're about 40 minutes in now.
Oh, wow. My bad.
Oh, yeah. You're stretching
it, I got carried away. So real quick, I'm just going to show you. This is the library. I'm running it locally. I'm running the tests. And this is, I kind of want to lead into what Steve was touching on for just a second and show like a couple interesting things I'm doing, and then I'll drop it. So let me open up the results of those tests. I'm not worried about what showed up there. Oh. So the library itself has really good coverage, except for the markers, because I just created those. Here's all the components. They all pretty much have 100% coverage. There's this thing called docs that has coverage. There's utilities that have pretty good coverage. Like I'm going to wrap all that up really, really soon. If we look at the code for the library, and again, I'll try to be really brief here, and I'll mostly focus on what Steve was asking about, or that we kind of touched on, not that you were specifically asking about it. I've written this library in a way that I generate most of the components and most of the tests from this singular JavaScript file called docs. So I'm documenting and describing and validating all of these components here. I don't even use prop types or TypeScript or anything like that, because fundamentally the only things you can pass into these guys are numbers and what I call point arrays, which are really just arrays of X and Y arrays. And then, the validators are all one of those two functions. There's a little text description and then some props. And then almost every single component, like I'll take an ellipse. This is what generates the React component. There's not even any React in it. Same thing with the tests. The tests use the docs to figure out what to test. So this single test, while it looks a little, remotely complicated, tests every single basic shape in here. And this one tests every single curve that's available. You do have an arc component and a cubic curve component and things of that nature. And all the components themselves just run through, or all the simple shape ones run through this singular thing called create simple component, which looks at the docs again, figures out the props and does all the validation. It does some interesting stuff in here, but again, there's no React in this at all. We don't get to that until this guy passes it to render. And the only reason that this does any React stuff is so that I can do the nesting stuff. Otherwise, it never even has any React in it whatsoever. And then the only thing that this is doing with these children elements is figuring out what the default attach should be when I was showing you how they nest. And all that does is figure out if it's end or start. And then it passes in, and it just automatically passes in an SX, SY, a CX, and a CY, and the component can figure out if it needs an SX, SX, or an SY, because all it's doing is rendering from that source path library. So all of this ends up just rendering out commands from that initial pure JavaScript library that I showed you. And the only time React is really involved is to take advantage of the nesting and, output something that React can listen to. But this is my square component. There's no React here. It's kind of neat. And then from those docs, if I go into example, this is the documentation site. If I go in here, all of the basic shape demos that you see on here, all of these, they just run through this one command, and they use the docs to tell you what to import, what the props are, and they also use them to generate, I'm stealing the term knobs for these guys. And that's it, man. The nesting and all that is very well described as far as at least as far as I'm concerned. Here's all the ways that these things are generated. If you're not using a marker, you can still put anything at the end of a line or a curve or in the center of a shape. You just nest it. So this last example is a line with an arc nested in it, with a circle nested in that. Or you could put text at the end of a line. Oh, and you can reverse it. So where this line would normally, or this circle would normally inherit the endpoint of this line, I just say attach equals start, and it pushes it to the start. And you can do both. This is a polyline with a little zigzag thing here. and I put some text at the end. I didn't have to say attach equals end because that's the default. And then on the circle, I say attach equals start. So you get a circle at the beginning and this text at the end. And then like one thing that I found that I can do, and I don't know if I really did it here, but here I just made a circle with a size of 0 because all I wanted was a common center point for the rest of them. And then I just offset those by various X and Y's, and that creates this. And on this one, the length of the line was 200, the start was 200, the end was 400. And then I just offset this by 100, and I put it in the middle. So sometimes you got to figure things out, but especially if you're nesting shapes, you really don't have to figure out shit. And I think I'm done. I am happy to answer any questions. I'm sorry for going so long.
That was phenomenal.
Wow.
Cool stuff.
Really fantastic.
Really incredible. Yeah.
Well, that's
Very cool, Joe. Totally cool.
Cool. I'm really happy with the library. My presentation, I didn't really have there's a lot to cover. So again, I'm sorry for going too long. But hopefully you guys dig this. I will throw some links into the thing. This is almost no human being knows about these libraries. Apparently 2 people know because I got 2 stars on this so far. But I have not been announcing this. I haven't been sharing it. I've been making like drastic changes I am doing releases to NPM. So you can install these. You just NPM save React or react-svg-path are on this guy. If you want to do plain old JavaScript, I wanted to name it path really bad. So I had to use @Joe Maddalone /path. And just to mention, this is the underlying library. It's one file. There's a couple groovy functions in here that do get exported. You could use like this radial points. I'm not going to do it, but now that I think about it, I could use this radial points thing, which generates a lot of the other shapes that you've seen because you just tell it like how big the shape is and where it lives, and it'll give you a certain number of points around it, X and Y coordinates. So I could easily use that to say, give me 12 radial points around the thing we just made, and then put text in each one of those. And then if the text was like not perfectly centered, what I would actually do is say, put a square there, and then put the text inside the square and inherit its center. So you could just do stuff like that. But then most of the code is just literal. I take the L command and the capital L command, I pipe them into line 2. One of them is relative, one of them is not. So there's, a bunch of those. And then when you get to the end of that, then it's just macros. And I mean, this is my rectangle, right? I just made it with my stupid ass commands. There's some more complicated ones here, but for the most part, like I said, you got to do some of this crap. I have a few junior high kids. They help me with this on the regular. But I feel like it's almost like a complete library other than documentation. And my intention is to next convert it over to Vue because I really want to learn a lot about the Vue internals and see if I could do the same thing with Vue. But yeah, that's I'll share those links. If anyone's looking to mess with open source stuff and you want to make a pull request, I will fucking be more than happy to review it and probably say, yes, let's do that. Because again, nobody really knows about this right now other than you guys. But I think there's something here. I think there's something really cool here.
No, it's nice. I think the macro thing was a really good idea because it gives you that way gives you extensibility and end users extensibility. For some of my projects, it's totally something I need. I've got a feature request for you.
Please.
Intersection of a line with a circle. I have to draw points. I'm drawing paths for, guess what? Dog training, right? As you would be stunned to imagine. And one of the things I want to do is do the dog's path as wrapping a circle and then going on to another location. So I need to find the intersection points of, say, 2 circles.
So I would
be able to draw the partial path
to get a look at maybe offline at some point. Well, online of course, but offline from the meetup. love to get an example of like what you're trying to do and see if it's something I already have or if it's something I could add. Because my whole thing has been, like I said, I've got a bunch of diagrams and charts in here, which are cool. And that's, in my mind, it's like what people want to see. But the next thing I was going to build is like a really intricate schematic. Like I was going to, I told my kids, like, we'll do Millennium Falcon. You guys will help me. But they're like, no. So maybe something simpler, some electronic schematics or something. Like, I actually think there's like something I really enjoy about building those and being able to build them in a super scalable way. It's all SVG, so you can resize this to whatever you want. And like just not have to think about it. Like the most complicated thing for me in this was asking my kids, like, how do I come up with this, like a common scale? And they were like, you just divide it by what it really is. And I was like, duh.
Well, if you need a suggestion for a proof of concept project, maybe an oscilloscope display would be a cool thing to use.
First, let's start with how to spell it.
Oscilloscope.
Oscilloscope.
I was
so
even
close.
That's not even close.
You got there.
Would this be an idea of what it should create?
Yeah, so it'd be.
I could definitely create that. If I understand the inputs, then I could definitely that one. I mean, just to be clear, I didn't really cover them because I don't have knobs on them. I mean, you can create. There are 3 common curves you can create in SVG: an arc, a cubic Bezier or whatever, and a quadratic Bezier. So you can definitely do those in here very easily, but I just don't have like a ton of documentation on them. So I imagine that if I understand the points and if I have an array of points, which is what I would need to derive from the input, then I could absolutely create what I just saw at least. Like I don't think that would be complicated at all.
Somebody hands you an array of measurements, and you just draw the lines between those points, and you auto sequence. Well, no, you auto sequence from left to right, and then just keep plot. It's more like graph plotting than anything else.
Yeah. So, and one thing to mention is, like this guy here, I think maybe I brought it up earlier. I'm not positive, but this, like, D3 has an awesome function or class called D3 scale. And I use that here to figure out the Y scale. Like, I'm not opposed to that stuff. Like all I have to do is give it a domain and an actual range, and it'll transpose those numbers for me. So if my domain is from 0 to 5,000, but my actual height is only from 0 to 250, it'll figure out, like, when I pass it in something that's from the real range into my range that I can actually use, it'll figure out where that should exist and give me that kind of relative distance. So if anything, I am not opposed to using D3 because I know I mentioned that earlier. I just personally, if you've ever used D3, you've definitely run into that situation where, your line chart all of a sudden became a bunch of fucking squiggles and you have no idea what happened. So for me, it's much easier for me to say, well, I use D3 to generate this scale, and then all the rest of it, like, I have total control over. I know where I positioned a line or text or something like that, and if something goes wrong, it's right here for me. Like, I know I wrote it, and but I didn't have to, like, spend a bunch of time thinking about a lot of the geometry for it. I said I want a curve from this point to that point, and it gave me that. So you can definitely use this with D3, or at least parts of D3. And the other one, just because it's cool, is this library called Dagger, or Dagre, that I love. I gave it kind of a set. I gave it like a JavaScript object that had a bunch of relationships between different objects, like parent-child stuff. It figured out all the points for me, and then I just drew out all the points I need. And on these React components, same thing with the regular path components, you can still do all the interactivity you want. So this guy is interactive. I clicked on node 8. I clicked on node 4. And same thing with the underline library. You know what? I don't. Oh, yeah, I do. Here it is. So you can click on these guys. All of it's, perfectly usable. It doesn't limit you from doing whatever interactivity you want to do. All it does is draw paths. That's it.
That library, you said it started with DAG?
DAGRE.
So does that stand for Directed Acyclic Graph?
Yeah, but I keep calling it Dagger because I don't know where DAGRE. DAG I get.
Yeah.
The RE part I'm not sure. So Dagger or Dugre, I'm not sure.
Agree.
But I've often been called upon to create DAGs, and I've used a very early version of my own library to do this in conjunction with that DAGRE library, and it's a really great way to, the same way that I was using D3 there to just generate a scale so I can figure out kind of relative positioning. I use Dagger, just give me the points. I don't need you to render anything. I can run it through my own, shapes and interactions that I want. So I think there's no reason not to use those libraries. But if you use this library, in conjunction with those, I do feel like I've created something that gives you maybe more of a sense of confidence and honestly a way to just like explore shit, to just kind of make quick changes and see what happens without being completely afraid or astonished by what happens.
Mm-hmm. Did I see that you were using some form of a testing framework?
Yeah,
it's
it's using Jest as a test runner.
Jest, okay.
Yeah, sorry, I stopped sharing, but I'm sure I didn't show it, but in the test, all the tests for the most part are generated by the docs as well. But I do think I'm using React testing library in there in a really dumb way, because if anyone's familiar with React testing library, I'm testing paths. Like there's not much to go on. So in the render method, I wrap it in a dummy SVG tag. And when I render it, because I just allow you to pass through any standard attributes, I just give it a test data ID and then I test for it. So I actually stick the test data ID in the rendered test, because it's not a website, and I try to go down the path where you use Cypress to test components, and it sucked. So I ended up writing my own little groovy thing that I'm like really happy with.
Yeah, I guess we're running out of time, but I just wanted to quickly ask you about your arcs and your circles. You said that you rendered them as discrete paths, which would be like micro segments to actually draw the
so
arc.
In the SVG path standard HTML, there is an arc command. So
you're using
I'm using the arc command. Everything that's rendered is a path. And so if you arcs would be certainly something more low level, closer to the metal, but there is an arc component or a path.arc command. But for the most case, it takes in the exact same variables that you would pass into the path D attribute.
Or an SVG element, probably.
Yes. Well, the only SVG element that takes any of these commands is the path. And all the library does is generate paths. So there's no recs, there's no squares, even though we call them that. None of that is in there.
Yeah. Well, I was just curious because based on what you said, I saw that your arcs and your curves were really smooth. So it's like something is optimizing for the actual display elements to make really smooth curves that you can't detect.
For sure. Unlike the circle segments and stuff, all of that is not in any like super special way. All of that is like already configured for you. So when you say I want a circle on this center X and Y, and I want it to have a size of this, it actually just draws two arcs for you. One that goes around one side, one that goes around the other side, but inside the same path command. So
very cool.
But it's the SVG engine in the browser that's doing all the real heavy lifting there.
Yeah. And like I might, you can control some precision with CSS actually. You can just say like geometric precision is crisp edges or optimized rendering or whatever. So that's all up to you. Like even in that, I don't even know if I really had a bunch of I think the only thing in CSS that I had there was to not fill a path. Because if you create a closed path, it's going to try to automatically fill with black if you don't tell it not to fill it.
Mm-hmm.
So you can treat any of those shapes like you would any other shape. You can give it a stroke. That animation that I was showing on the documentation site, that's just stroke dash array being animated. Like it's not actually drawing the thing. It's just filling it up. And then the length of the dashed array is long enough that it, by the time the next one gets there, it's emptied. I don't know. It's all just stupid CSS hacks for that type of stuff. There's no CSS or CSS recommendation or anything in the library that talks about CSS or anything. It's all just draw lines, and here are some things that'll help you draw very specific lines, and if they're closed, you can fill them. Actually, even if they're not closed, you can fill them up.
Gotcha. Very cool stuff, Joe.
Very, very cool.
Groovy.
Very cool.
It's
Very cool.
not time wasted, maybe.
Not at all. And
But Steve, yeah, I would like to, like, if you can hit me up with like even just an image of what you need to create or how it works, or maybe we can hop on a call sometime. I'm kind of looking for not edge cases, but interesting use cases.
Yeah, this is kind of a weird use case, so you may not be interested in it, but it's just enough geometry that I don't want to solve it. So I'm hoping someone else.
I don't want to solve it either, but I kind of feel like if we have a library that solves it for us, fuck it, we don't have to do it again, right?
Yeah, do it one time.
Yes. Yeah, I don't have to remember.
Only one person has to figure it out. Yeah.
Yeah. I'm kind of waiting for somebody who's like really, really into geometry to show up and be like, what the hell are you doing, dude? It's just, like, yes, you're getting away with it, but